Okay, we're going to be looking at a problem in angular momentum. In this case, we are particularly interested in the vector form of the angular momentum and using unit vectors. A 0.004 kilogram bullet is traveling horizontally. It has a speed of 1.0 times 10 to the third meters per second. It enters an 18.9 kilogram door, embedding itself 9.10 centimeters from the opposite side that the hinge is on. The 1 meter wide door is free to swing on its frictionless hinges. We want to demonstrate by using unit vector notation that the angular momentum of the particle is L equal mvd, regardless of how far away it is. And then let's calculate the value. First thing you want to do is write down what is L in terms of R and P. And of course, L is equal to R cross P. It's the cross product of R and P. And it will form another vector. What is R? Take a minute and draw what you think R is. Okay, R is the vector from the point of rotation to the projectile. What is P? Draw a vector representing P. And of course, P is just simply in the direction of the projectile. It's the mass times velocity. What are your axes? Take a minute and draw your axes. What is the x-axis and what is the y-axis? And I'm going to draw my own. And I show the y-axis in the positive vertical direction and the x-axis in the positive horizontal direction. What is P in terms of unit vectors? Of course, you want to take a minute and write down what you think P is in terms of unit vectors. And of course, it's in the positive x direction, which is I hat, so P, the vector, is P the magnitude times I hat. What is R in terms of unit vectors? Take a minute again and write down what you think R is. If you need to pause the video, pause it. Of course, R is, we have a Rx component that's in the I hat direction and an Ry component in the J hat direction. What is Ry equal to? Take a minute, examine the figure, look at the vector R, examine the components of the vector, and tell me what R is equal to, Ry is equal to. And of course, Ry is D. Now, if you don't believe it, you need to work it out. Just pause the video and convince yourself that's true. What is the angular momentum? Okay, write it down in terms of vector notation. Of course, L is equal to R cross P, and I'm going to write down that R is Rx I hat plus Ry J hat, quantity crossed into P I hat. And of course, why does the I hat cross I hat go away? You're left with Ry J hat cross P I hat, and that comes out to be minus dmv, which can be arranged to be minus mvd k hat. What is the magnitude of L, the angular momentum? Well, you want to write that down and then calculate it. And of course, L is equal to mvd, and the magnitude is 3.63 kilogram meter squared per second. A couple points, we know that that's in the minus k hat direction. The other thing is we know that the system is the hinge and the projectile. When the projectile embeds into hinge, what is the angular momentum of the projectile and hinge? You should be able to answer that immediately. End of problem.